In this video, we're going to look at chapter 16, which focuses on weak acid-base equilibria. So we start the chapter with weak acids, and we look at how we can define a weak acid equilibrium using principles from chapter 14. And we also define the equilibrium constant for a weak acid equilibrium, which is called the acid dissociation constant. So it's basically a K, but it has a special name, K, and it gets a special symbol, Ka. But the same principles apply to as what we looked at in chapter 14 to K. And then we look at some type 1 problems where we work from the equilibrium concentrations to determine Ka, and vice versa. We look at some type 2 problems where we get Ka in an initial concentration and use those to calculate an equilibrium concentration of the H3O plus, for example. And then we look at a few we look at a few examples where we have polyprotic acids, or we look at what happens when we have a polyprotic acid and we want to figure out the fully deprotonated conjugate base. Okay, and then we switch gears. So we're sticking with this idea of having just one thing in solution, right? So that we either had, in the first part, we just had a weak acid in water and that was it. And so sticking with that kind of concept, we move on to weak bases where we just have a weak base in water and nothing else. And so we define the weak base equilibrium, just like we did for a weak acid. We look at how to calculate Kb, and we do the same exact calculations with weak acids, but we substitute in weak bases. It's the same exact idea, it's just with Kb instead of Ka. Then we go into sort of the second part of the chapter where things get to be a little bit more complex. So we look at what happens when we have salt solutions that have acid-base properties. So in essence, we figure out whether a salt will be acidic, basic, or neutral. And there's some rules for how to do that, and there's a procedure for how to do that. And then we look at how we can use the Ka or Kb information to determine the pH of a salt solution. We also develop an equation where we can relate Ka and Kb to Kw, and that's really important for working with these salt solutions where you might not know Kb or Ka, but you can convert one to the other using Kw. Then we go into the next major section, which is buffers. And buffers are really, really important, both in terms of chemistry, but also in terms of biology. A lot of things in biological systems, almost everything in biological systems, is buffered to some degree. And they're really important for regulating pH. So we learn how to derive the Henderson-Hasselbalch equation, which is a very convenient equation for working with buffers. It allows you to calculate the pH of a buffer in the context of just the pKa or the Ka and the concentration of the acid in its conjugate base. And then we look at some methods for making buffers and how to do those calculations, and we look at what would happen if you added a strong acid or base to a buffer and how to do those calculations. And then we conclude with titration curves. And what basically titration curves are is they take all of this stuff that we've been doing. They take part 1, part 2, part 3, and part 4 stuff, and they stick it into one giant concept where we basically use all of the calculations that we learned to analyze a titration curve, where we add a strong base to a weak acid or vice versa. We also look at strong acid, strong base titrations in this chapter as well. But yeah, so that's kind of how it rounds out and ends with titration curves. In the online Blackboard, in the resources folder, we have our regular drill questions, we have our slides, we have a couple of lecture problem solutions, and then there's a video that goes over some weak acid titration. So you might want to take a look at that. I believe that is supplemental to the videos that are on YouTube. It's just another worked out example if you want to give that a try. And we also have the practice questions for the exam that are coming up. So that's all available to you in the resources section on Blackboard.